I want to do a few examples of multiplying and dividing rational expressions where we have some more factoring to do. Okay, so for each one of these examples, we're going to perform the indicated operation, simplify it, and if applicable, write the restricted domain. Okay, so in this first example, I have x squared plus 8x plus 16 all over x squared minus 12x plus 36 times x squared minus 4x minus 12 divided by x squared plus 6x plus 8. Okay, so I have four quadratics there, right? Two in the numerators and two in the denominators. So we can multiply straight across, but that would leave us with like a quartic polynomial, right? So if we really want to simplify this, what we need to do is look at the factors, okay? So in that first numerator, x squared plus 8x plus 16, factors of 16 that add to 8, well, 4 and 4, right? So it's really going to be x plus 4 quantity squared, and I'm going to go ahead and write it as x plus 4 times x plus 4 because I think it'll help us out. So in the denominator of that fraction, I'm going to have x squared minus 12x plus 36. All right, factors of 36 that add to negative 12. Well, I'm thinking negative 6 and negative 6, right? So x minus 6 quantity squared. I'm going to write that out as x minus 6 times x minus 6. Okay, now I'm multiplying everywhere, right? So I'm just going to draw this line. Yeah, multiply the numerators together. So x squared minus 4x minus 12, factors of negative 12 that add to negative 4. I'm going to go with x minus 6 and x plus 2, right? Negative 6 plus 2 is negative 4, but negative 6 times 2 is negative 12. Okay, and then in the denominator, that last denominator I have is x squared plus 6x plus 8. Okay, so factors of 8 that add to 6, I'm going to say 4 and 2. So x plus 4 times x plus 2. Okay, all right, and you notice I'm multiplying. I just multiplied the numerators and the denominators together. So I have these four factors in the numerator and the four factors in the denominator. And now I'm asking myself, okay, are there factors of 1 that can just go away? X plus 2 over x plus 2 can cancel. X plus 4 over x plus 4, x minus 6 over x minus 6. Okay, what am I left with here? X plus 4 over x minus 6, right? And in terms of the hidden domain restrictions, I would say that x can't be negative 4 and x can't be negative 2, right? So those are the ones that we canceled out. We also canceled out the factor of x minus 6, but we still have an x minus 6 in the denominator, so we don't need to list that restriction. Okay, so hopefully you're getting a feel for this. If you're good at factoring and you enjoy factoring, none of this is so bad. If the factoring is a struggle, you'll get a lot of good practice doing these problems. Okay, so this one is a division one, okay? So before you even start, some of you are good enough that you can start factoring and flip the second fraction at the same time, but I am just, because I will forget, right? So I'm going to say y squared plus 3y over y squared minus 9, and we're dividing that by y squared plus 5 minus 14 over y squared plus y plus 4y minus 21. But we have to multiply by the reciprocal of that, right? So the reciprocal of the divisor is y squared plus 4y minus 21 divided by y squared plus 5y minus 14. All right, so now that we're multiplying, we can just start factoring everything, right? So in that first numerator, y squared plus 3y, there's no constant term, right? Okay, so when you have that, y is common to both of those terms, so just factor a y out. So we have y times y plus 3, right? If you distribute that through, you get y squared plus 3y. And then in the denominator there, y squared minus 9 is the difference of squares, right? So we're going to have y plus 3 times y minus 3. Okay, now since we're multiplying everywhere, we're going to multiply the numerator times the numerator and the denominator times the denominator. So when we look at that numerator of y squared plus 4y minus 21, I need factors of negative 21 that add to 4. and I'm thinking 7 and negative 3, right? So I'm going to have y plus 7 times y minus 3, right? You can FOIL that out if it helps, but 7 times negative 3 is negative 21, and 7 minus 3 is 4. Okay, and then in that denominator there, I've got y squared plus 5y minus 14. I need factors of negative 14 that add to 5. Okay, I'm thinking 7 and negative 2, right? So y plus 7 times y minus 2. Okay, because 7 minus 2 is 5, but 7 times negative 2 is negative 14. Okay, so now that I'm multiplying everywhere, right, I can start canceling factors of 1. So what goes away here? Y plus 3 cancels, y plus 7 cancels, y minus 3 cancels, and what are we left with here? Y over y minus 2. Okay, and what is restricted here? Y cannot be plus or minus 3, right? And y can also not be negative 7, right? 3 or negative 3 or negative 7, any of those would make the denominator 0 in our original expression, okay? And we know that by just looking at those factors that we canceled out, right? We canceled out the y plus 3, we canceled out the y minus 3, we canceled out the y plus 7. Okay, good. Lots of factoring involved. Okay, let's try another one. So this is a multiplication example. We don't have to multiply by the reciprocal of anything here. We can just multiply straight across. But we've got a lot of factoring involved, right? So let's try it. I've got 18 minus 6x divided by 25 times x squared minus 4 times 15x to the fourth minus 6x cubed, all divided by negative 2x squared plus 5x plus 3. Okay, so I have to do a little factoring here, right? So in the first numerator of 18 minus 6x, I can factor a 6 out, right? So I have 6 times 3 minus x, yeah? And in that denominator, 25x squared minus 4 is the difference of squares, right? So I'm going to have 5x plus 2 times 5x minus 2. Right? And because we're multiplying, I'm just going to extend the line here, right? So in that other numerator of 15x to the fourth minus 6x cubed, what can I take out there? Well, amongst the numbers, I can take out 3, right? And amongst the variables, I can take out x cubed, right? So that's the greatest common factor there. And what's left over there? 5x minus 2, right? 3 times 5 is 15. X cubed times x is x to the fourth. 3x cubed times negative 2 is negative 6x cubed. Okay, yeah, we got it. All right, now in that last denominator, I noticed that the leading coefficient is negative 2x squared plus 5x plus 3. I'm going to factor out a negative 1 from that quadratic because I like my leading coefficient to have a positive value. So that will give us 2x squared minus 5x minus 3. Okay. So I know I can cancel some stuff out. I just like to leave stuff until the end. You don't have to, but I want to factor this quadratic here. Okay, so the 2x squared minus 5x minus 3, I'm going to have a little aside out here. So if I've got 2x squared minus 5x minus 3, multiply a and c together, right? So 2 times negative 3 is negative 6. And I want factors of negative 6 that add to negative 5. So negative 6 times 1 will do it, right? Because negative 6 plus 1 is negative 5. So 2x squared minus 6x plus x minus 3 is what we'll have there. So I just took the negative 6 and the 1 and I rewrote the middle term, right, as minus 6x plus x. And then I can factor by grouping. All right. So in that first group, I can take out a 2x, right? And I'm left with x minus 3. And then I have x minus 3 down here, and I can't take anything out of x minus 3, right? But remember, there's a little 1 out front. So now you can factor out an x minus 3 from both of those terms, and you're left with the 2x plus 1, right? So we have x minus 3 times 2x plus 1. Okay. So x minus 3 times 2x plus 1. Okay, so now I've got all the factoring done. What can I cancel out? I can cancel out the 5x minus 2, right? And not a whole lot else, huh? I see the 3 minus x and the x minus 3, and I think, well, if I factor a negative out from one of them, that will do it. I also notice I've got this negative 1 here. Why don't I just distribute it that back through? That would do it too, right? I need a factor of 1 coming from somewhere. I should say a factor of negative 1. Okay. So there's our numerator, and then I've got 5x plus 2 times negative x plus 3 times 2x plus 1. Okay, negative x plus 3 is the same thing as 3 minus x, yes? Okay, so we can cancel that out. And I'm going to be left with, you can go ahead and multiply things. You can leave things in factored form as much as you can, but like up top there, I think I'm going to have 18x cubed. It's a little bit cleaner to look at. Divided by 5x plus 2 times 2x plus 1. Okay, now let's think about the domain restrictions for a minute. Okay, so we canceled out, what did we cancel out? We canceled out 5x minus 2, right? So what makes that 0? 5x equal to 2, x is equal to 2/5. Okay, so x can't be 2/5. And what else can't x be? X can't be 3, right? Because we canceled out a 3 minus x. If x is 3 in there, that gives us trouble. Okay, so there was a lot going on in this, right? With the factoring and noticing difference of squares and factoring out greatest common factors of things. So, and don't forget about the domain restrictions too, the stuff that those factors that you cancel, what makes them 0. All right, so this is a division problem, 4a squared minus 1 divided by a squared minus 4, divided by 2a minus 1 over 2 minus a. Okay, so the first thing, like I said, some of you can go ahead and start factoring right off the bat. I'm just going to take a moment and rewrite this problem, 4a squared minus 1 over a squared minus 4 times 2 minus a over 2a minus 1, right? So I'm multiplying by the reciprocal of the divisor, that second fraction there. Okay, now I'm going to start factoring. So 4a squared minus 1 is actually the difference of squares, right? 1 is a perfect square. So I'm going to have 2a plus 1 times 2a minus 1 times 2 minus a, right? I'm just going to go ahead and multiply the numerators together there. And then in the denominator, a squared minus 4 is the difference of squares. So I'm going to have a plus 2 times a minus 2. And then I'm going to multiply that by 2a minus 1, that other denominator there, okay? So 2a minus 1 goes away. Now that I've got everything fully factored, I can start canceling things. So it might appear that that's the only thing that cancels here. But remember, when you've got 2 minus a and a minus 2, what can we do to that? Factor a negative out. We have 2a plus 1 times a negative 1, right? And then factoring a negative out from there will give us negative 2 plus a. Yeah? And then in the denominator, we have a plus 2 times a minus 2. Okay, so negative 2 plus a is the same thing as a minus 2, right? If we rearrange those terms, so those are the same factor. And I'm going to go ahead and distribute the negative 1 through to the other terms. So I have negative 2a minus 1 and then a plus 2 in the denominator. Okay. All right, so that simplifies to negative 2a minus 1 all over a plus 2. If you wanted to leave that negative factored out, that's okay too. But at any rate, this is our simplified version. And not quite. What are the restrictions on the domain here? So we had 2a minus 1. That's one that we canceled. So what makes that 0? So we've got 2a equal to 1. A is equal to 1/2. Okay, so that means a can't be 1/2. And a can't be 2, right? Because we crossed out that a minus 2. So these problems can be kind of fun as long as your factoring skills are up to snuff, right? If you're comfortable with factoring and seeing what you need to do with something, these problems are really not so bad.